Okay, this is June 2005, Module 4, Question 5. What is meant by a field of force? Well, field of force is the region where force is experienced. So it's the region in which an object experiences a force. Now, again, that has been asked fairly regularly over the last few years, so it's something that you need to know. Sphere of mass 1.6 grams has an electric charge of 2 microcoulombs dropped into a vacuum from a certain height between two metal plates. Again, this is another question which is similar to one that was asked before. The plates are separated by 100 millimeters and a PD of 80 volts is applied between them. First of all, we're asked then to calculate the magnitude of the gravitational force acting. Well, this is a fairly straightforward calculation. We're going to use W equals mg. We just need to be careful there that it's 1.6 times 10 to minus 3 kilograms times then 9.81. Fill that in and calculate that, and that gives us that W is equal to 0.0157 newtons or 0.016 newtons. Then calculate the magnitude of the electrical force acting on the sphere. Well, we're going to say here, well, E is equal to V over D, and then E is equal to F over Q. So when we combine both of those together, that means that F is equal to E times Q. So, well, E is equal to V over D, so the V was, if we take a look up in the question, was 80 volts, so it's 80 divided by 100 millimeters, so that's 0.1 of a meter, times, and the charge was 2 microcoulombs, so that's 2 times 10 to minus 6. So that gives us a force there equal to 0.0016 newtons, so 0.0016 newtons. Okay. And again, this entire question has the gravitational force is acting pulling it down here. If this is a positive charge, it's going to be pushed across there and pulled down at the same time. We find the gravitational force just using W equals mg. We find the electric force then by first of all finding the field strength and then multiplying by the charge to work out the force. We're now told that the forces in 1 and 2 are both constant throughout the fall. Calculate the angle theta to the horizontal of the path of the sphere just before it strikes the ground. So if you remember back to the diagram, then what we have got is we have got a charge which has been pushed across horizontally and been pulled down. So consider what's happening here. It's been pushed across like so, and it's been pulled down like so. We're going to calculate the angle to the horizontal, so it's going across, and the value there is equal to 0.0016, and the value down is equal to 0.016 newtons and newtons, which gives us then a resultant force like so, and that angle we'll call theta. So we're going to just say tan theta is equal to the opposite over the adjacent, so that's 0.016 divided by 0.0016, which means then that theta is equal to the inverse tan of well, that's approximately 10, so theta, whenever we put that in and calculate that, is equal to 84.2 degrees. So 84.2 degrees is the angle that it makes with the angle that it makes with the horizontal. Then we're asked to sketch the path of the sphere as it falls between the plates on figure. So I need to go back to my diagram, and now we're just going to ensure that we get a force, and it'll be a straight line. So I need a ruler to do that, if I can get my ruler out here. Okay. And it's going to be coming something like so. It's 84 degrees, so it must be going something like that. So it's a fairly steep line there with an angle to the horizontal there of 84 degrees. And that's the last part of that question.